Hi students, welcome to the next sessions from magnetic effect of current, and which we call it as force on a current carrying conductor. So let's start with the headings. Force on a current carrying conductor placed in a magnetic field. So you can write on the heading, force on a current carrying conductor. Current carrying conductor placed in a uniform magnetic field. Uniform magnetic field. Force on a current carrying conductor. Force on a current carrying conductor. Where it is placed? It is placed in a uniform magnetic field. Magnetic field is uniform. So we will see we have a magnetic field directing in these positions, and the magnetic field is B. And what I have done means I placed a current carrying conductor like this. This is a current carrying conductor which is carrying the current in this direction I. So we know electrons are moving in this direction. In another way, we can say positive charged particles are moving in this direction. So we are interested on the positive charged particle. So the motion of an electronic charge, okay, and a positive charge or a negative charge. Negative charge is opposite to the motion of the current. Positive charge is in the direction of current. In short. Okay, so what is the force will be here? Of course, we know force will be equal to Q into V cross B or QVB sine theta. Okay, in our case, let me write it as QVB sine theta. Angle between the velocity vector. So this positive charged particle I am considering here in the direction of current. So this is moving like this, so which makes an angle theta with respect to the magnetic field, and that is the value called theta here. Next, what is the charge will be here? It's positive charge, so I have written as E plus charge. The velocity is called, velocity of the charged particle is called drift velocity. This you have learned in current electricity. Velocity of the charged particle is called drift velocity, and V and then magnetic field into sine theta. This is what we know, E plus VD B sine theta. Electronic here charge E plus is a one charge. Okay, so let me consider for one volume means 1 meter cube volume, you have one, or you can consider like for this is made up of like 1 meter cube, 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 1 meter cube. So there are lot of 1 meter cubes are arranged. Its length is equal to L and cross section area is equal to A. So what is the volume of this one? What is the volume of the wire? Volume of the wire is equal to area of cross section into its length. Okay, normally A into L. So A into L is the total length of the wire. So let me assume E plus, it's one charge which can be somewhere here. So 1 meter cube means maybe this area is called 1 meter cube. So this 1 meter cube contains n number of charged particles. So 2 meter cube contains how many charged particles will be there? 2n. So what is our volume? If you have taken a small cross sectional area will be here, and whose length is equal to dl. Its length is equal to dl. Then we say A into dl amount. L is the full length. If you are taking a small piece, A into dl contains A into dl times of n number of electrons. So this is the force due to one charged particles. So what we are going to do? Force in a current carrying conductor placed in a magnetic field means the current carrying conductor is consist of large number of positive charged particles. but this is the force given by one charged particle. So I can take it as a dF. It is a small force given by one charged particle, but overall we have how much? Overall we have dF will be equal to, so this is not 1e. Now we have this volume contains this many number of charged particle, a dl n number into electronic charge into drift velocity into sine theta. This many number of charged particles will be there. This is for one charge. So if I want to get full charge, what should I want to do? I want to integrate. I want to integrate a dl n e plus vd sine theta. This is our expression. Now to get full strength, which means full strength means full current. Full current is contribution of large number of electrons. Okay, so this means give raised to F. So a n e v d sine theta integral dl. Integral dl is what is called L. So F will be equal to, in current electricity you have learned one equation, current is equal to NEAVD. NEAVD. This is the equations you have learning from current electricity. Current in relations with the drift velocity. So NEAVD can be replaced with the current and with drift velocity. So NEAVD all together will give rise to current. And what is extra will be, we have here magnetic field. So here we have magnetic field. So NEAVD, all this factor is give rise to current. So BIL into sine theta. So this can be written in vector format. F is equal to I into L cross B. L cross B. F is equal to I into L cross B, right? BIL sine theta can be written as F is equal to I into L cross B. Suppose some other student derived this equation and he is written B cross L sine theta, which means you come to these equations like this one. You know current is a scalar quantity. Current is a scalar quantity, then B and L are vector quantity. L is the length vector, B is the magnetic field. Unit is called Tesla. So B and L you can written in true format. I anyway it's common outside because it's scalar quantity. L cross B you can write, or B cross L you can write. Which one is correct? Of course the color, the black one is right and the red one is the wrong one. Why this is wrong, why this is right? That is a question here. Very simple. Very simple. Why means, let's consider. See, L cross B. While I can say how to find cross product of two vectors. Immediately you may remember, sir, I, J, K in matrix format. It is there, absolutely right, but there is one method. I'll tell you one simple method. Listen very carefully to the board. Okay, you can complete up to this one. Then I into L cross B, I into B cross L. I told I into B cross L is wrong answer. I into L cross B, because why I am saying from this step there are two options for you to write, either in this format or in this format. I am saying the first format is correct, second format is wrong answer. For that I am giving a justification for you why I am saying like that. So you can pause the video, you can complete up to this, because I am going to wrap this area and I am going to teach you something else. Okay, something else means I am going to teach you the effect of magnetic field intensity over a current carrying conductor. So this effect I am going to teach you. Okay, so this effect, which means why the first equation is correct, why the second equation is wrong. This is the context of the discussion. So you can pause the video, you can complete it till here. I am going to clean this area. So far everything is pakka. Let's clear the board and we'll see. Okay, so I want to teach you some basics from first year. In case if you have not watched my other videos of from first year, I have to teach you this one. Okay, this is a fundamental. Anyway, more details are available in the first year videos, but yeah, here let's see. C is equal to A cross B. Two vectors are there. How to find the direction of this one? For example, A is in this direction and B is in this direction. Then for this one, we will use right hand palm rule. First vector direction, you have to place your forefinger like this. Then B direction, you have to fold it. So you are folding in the B direction. Then where your thumb is coming outside. So thumb is coming, I can say outside. That means in the Z direction. A is in the X direction, B is in the Y direction. Then according to this rule, according to the palm rule, A cross B, B is like this. So the thumb is coming towards you. Thumb is coming towards you means that is the direction of your vector in very simple way. Okay, so this is clear to you. Now what I am going to do means, in our context of discussions, let's become very clear. This is a magnetic field. This is the direction of current, or this is the direction of positive charged particles, and this is the direction of our length vector also, length vector starting in the direction of current. Okay, now what we need to do? L cross B. Pakka listen, L cross B. So L is in this direction, L cross B is what direction? B is in the direction. So L cross B, I am folding my fingers. Where my thumb is going? Thumb is going into the board. Thumb is going into the board means that thumb is representing the resultant will be here. See, this is the force and this is something like L cross B. So L cross, L means this finger, right hand, not left hand, right hand. L cross B, I folded in this direction. My thumb is going inside. So force is inside. This is what I got from the basic vector rule. Okay, so basic vector rule. Vector rule. What is that rule is called? Right hand thumb rule. Right, based on the right hand thumb rule, we got this one. Next, what I am going to apply? I am going to apply Fleming's left hand rule. So both answers should be correct, right? Fleming's left hand rule. What is the Fleming's left hand rule speaking about? Like this. Middle finger in the direction of the positive charged particle or current. B is the magnetic field. This will be the force. Thumb will be the force. So let me apply this law. So current is going in the direction. So my fingers, my middle finger is like this. But magnetic field is what direction? Magnetic field is in this direction. So magnetic field has to be in the directions. So this is the direction of magnetic field. You can see this is the direction of magnetic field, but my currents are going where? Currents are going in this direction. Where my thumb? My thumb is into the board. My thumb is into the board. So F is inside or into the board. As per Fleming's left hand rule, LHS, Fleming's left hand rule. So both yielding the correct result. Because if I am taking L cross B, I will get a force direction that exactly same as if you are taking Fleming's left hand rule. Both wise it's giving the same direction, which means this is a correct statement. But if you take B cross L, so B is in this direction. So B cross, so B cross L, where your thumb is coming outside. So as per this one, there are two conditions here. One is basic vector rule and one is Fleming's left hand rule. So if you apply in this case, as per basics vector rule, what is a vector rule? Right hand thumb rule. As per the right hand thumb rule, F outside, force outside. But again here, as per Fleming's left hand rule, means that is very clear. Okay, Q V cross B. So Q means positive charged particle direction, V cross B. So Fleming's left hand rule. F is what direction? F is inside. Now, if you see, these two contexts will be here. These two contexts. These are contradicting to each other. Contradicting to each other. In physics, there is no contradiction. Everything should be based on certain law. So this is contradicting. This is contradicting means this for me it is not acceptable. I cannot accept it. There is no contradictory statement should not be there in physics. Anywhere, any chapter, no contradiction. So this is a contradiction. Basic vector rule is saying a force is right side. Fleming's left hand rule is saying force is inside. So basic vector rule you are applying on B cross L. So you are getting force outside. Fleming's left hand rule, you know Q V cross B. So Q is the direction of the charges, which means Q into V cross B. V is the velocity in the direction of the charges, and if you apply Fleming's left hand rule, you got force inside. So in case of for these equations, both are matching. This is a right answer, but in these cases, Fleming's left hand rule is always says force is inside, but your vector rule says force is outside. Contradicting, not acceptable, wrong answer. Hope the statement is clear to you. So this is the basics, fundamentals in physics. Okay, how to find the direction of the vector quantity. Okay, super. So let's move to we'll do certain questions and we'll see how much our concepts are become stronger and stronger for you. Okay, so let's do some questions, some problems. So let's have different question. The first question, find the force experienced by find the force experienced by the current carrying conductor. The current carrying conductor. Find the force experienced by the current carrying conductor. So let's have a diagram is given. The magnetic fields are where? Into the board or out of the board? Cross indicate into the board. We have placed a current carrying conductor and current is flowing in this direction. Okay, and its length is equal to L and magnetic field is given. And this makes an angle 30 degree with horizontal. So 30 degree with horizontal. This makes an angle 30 degree. Okay. So this carrying a current of I. So we need to find the force experienced by the current carrying conductor. Conductor is placed in magnetic fields. We know for a conductor I into L cross B, which is equal to I vector format, which is equal to ILB sine theta. Theta is what? Theta is, again I told, angle between L and B. Do not take 30 degree. 30 degree, wrong answer. Wrong. Pakka wrong. Stupidity you are doing. If you are taking 30 degree will be there. If you think that, gone. It's wrong. L means, see, L is in this direction. L is in this direction. This pen is L is in this direction. So L is in this direction. Magnetic fields are into the board. See, magnetic fields are into the board. What is the angle between these two? 90 degree. This 30 degree is pakka given to you to confuse you. Okay. This is a trap. This 30 degree is a trap. So it's not 30 degree. So which means ILB sine 90. If you put 30, gone. Okay, you will get ILB. ILB is the option. ILB is the right answer. So if you look, will be here in 4 options. The options will be formulated like this: ILB by 2, ILB, 2 ILB, and 3 ILB, something like this. Few group of students will fall under this category, ILB by 2, because they put sine 30 theta is equal to 1 by 2. Gone wrong, minus 1 mark gone. Entrance examination minus 1. No, that's wrong answer. What's the right answer? Here it is called ILB. Option B is the right answer for this question. Perfect. Fine. Okay. So that question is clear. Let's do another question. Same question, find the force experienced by the current carrying conductor placed in a magnetic field. So one conductor like this, another conductor like this, equal length. Okay, let's have equal. So this angle is given as 30 degree and this angle is also given as 30 degree, and this length is given as L vector and this length is given as L. So what we will do in this case? So what we are going to do in this case means L and B will be there. Okay, so two conductors, so of course two forces will be there, right? Okay, so this is the L vector and magnetic fields are where? Into the board. So first we'll consider like one by one conductor. Okay, so let's have a look. So let me consider this is conductor number 1, this is conductor number 2. Okay, so I am redrawing the diagram. 1 and 2 are located like this, which are making an angle of 30 degree to the horizontal. So first current is like this, second current is like this, length vector is also in the same directions, same length also. So let's say L cross B. So L is in this direction. See, L cross B. B means where? Inside. So you can simply apply L cross B. L cross B means right hand thumb palm rule. Palm. So L is in this direction. So this is a direction of L. This is a direction of L. So listen carefully. L cross B. B means where? Inside. Magnetic fields are inside. So L cross B. So where your thumb is like this, which means the force given by the current carrying conductor is like this. What I have applied will be here right hand palm rule. Right hand palm rule. So palm rule. Right hand, using right hand palm rule, you can find the direction of the cross product of two vectors. Coming here, L cross. So L cross B. Okay. So we have to use our right hand. We have to use our right. Okay, here direction of current is okay. One mistakes will be here. Let me take the same color. The current direction is like this. So this is I is flowing like this. So the length vector is taken in the direction of current. Sorry for that, I marked it wrongly. The currents are coming and going like this. So here also currents are going like this. This is the direction of current. So currents are coming like this one. So the length vector is also in the direction of current. You can take length vector in the same direction of current. This is L and this is L. Okay. Now we are going to see what is the direction of the force given by the second conductor. This is second conductor, right? L cross. See, L cross B. L cross B. I fold L cross B. L cross B. So where my thumb? My thumb is coming here. Thumb is coming here means this is the direction of force. So two force we got, right? Next, the thing is like we just join these two forces just as an addition. Okay. Now we have to see this horizontal direction, this horizontal direction. What is the angle made with this horizontal? See, these two lines will be here. This is 30 means what is this angle will come? 30. What is this angle will come? 60. So this is 30. So an horizontal lines parallel to this one and this also 30. So this become called 60. Okay. So this force can be, F is in this direction, can be splitted into two components. Listen very carefully. What is this will come? The side nearer to theta is called F cos 60. And what is the other one is called f sine 60. Similarly, bottom we have f like this one. So horizontal and vertical. So we have an horizontal, again f cos 60, f cos 60, vertical f sine 60. Theta ke pakkathil irukana side. The side nearer to theta, it's called f cos 60, and the other one. So this is a resultant vector. See, this is a resultant vector. So this can be splitted into like. So this is like a, this is like a, I'll call this like a full apple. Can be splitted into two apple. If this is theta, then this become f cos theta, and this become f sin theta. So f cos theta is a half apple, f sin theta is a half apple. So these two together is called f. This f can be splitted into f cos 6, f cos 30, and f sin, f cos theta and f sin theta. Then f is no more exist. Now if you see, will be here. F cos 60, F cos 60, two vectors are acting in this direction. F sin 60, F sin 60, both are same length, carrying same current, everything, same magnetic field. F will be same. Two vectors are acting in the opposite directions will cancel each other. Correct, Tane? Two vectors which are acting in opposite directions are cancelling each other, which means this f sin 60 cancel with this one f sin 60. Now here f cos 60, f cos 60. What will happen to the f cos 60? F cos 60 will get added up. So total force, now I can say F net will be equal to 2f cos 60. So this with this will cancel. This with this one will cancel each other. So what is 2? F means ILB. ILB sine of 90 into cos of 60. Angle between L cross B. L is in this direction. L is in this direction. Magnetic fields are inside. So angle between L and B is 90. That's what written as F is equal to I into L cross B. LB sine theta. Theta equal to 90 degree. So what we are getting finally, 2ILB cos 60 means what? 1 by 2. Sin 90 is 1. So the answer is called ILB. ILB. Okay. This is the very traditional method to answer this one. Now I will give you a shortcut. Okay. Don't think like this is a very complex thing. This is I just used the vector method. Vector method very elaborately we are studying in first year. Okay, if you watch the first year videos in between, or once you are watching our first year video, you will get a more idea about vectors. Now this is very clear, very short, very simple. What we are doing, F is in this direction. This angle is given in the question as 30 degree. So this angle is 30 means this angle is 30. This is 60. So total is 90 because this is perpendicular to this one. Next, F is splitted. F is split as F cos theta, F sin theta. So this will comes as F cos 60. So if this F is bending to this side means you have to take this angle 60 degree. So F cos 60, F sin 60. Next one is F sin 60. So this is like this one. The bottom is like this F. So this is splitted into F cos 60, then bottom one F sin 60. This is what I have written. So both will get cancel each other. This will get added up. So total force equal to this one. Next, you can pause the video. You can write down this one. Next, I am going to teach you a shortcuts method to do this one. Okay, you can do like this. This is also a correct method. Okay, very perfect method. There is nothing wrong with this one, but I want to teach you one shortcut method which will be helpful for you to answer in the examinations in a very quick way. Listen very carefully. F is equal to ILB sine theta. I know theta is the angle between. This is what I am going to teach you is how you can answer this question in 10 seconds. Sorry, how you can answer this questions in 10 seconds. Okay, so theta is the angle between L and B. Theta is the angle between L and B. Okay, so this is what we are going to do. Here one important thing is will be there. L is the displacement. L is the displacement. Displacement in the sense, for example, if you have one conductor like this, one, then this is the displacement will be here. L is the displacement will be here. But if you have two conductors, then final point minus initial point. See, listen, which means I have to say final point minus initial point, shortest distance. Final point minus initial point, shortest distance is called the displacement. See, here as I told, current is coming from here and going here outward. Okay, so this is, in this case, this is the start point. This is the final point. So distance between final point minus initial point, which means I am drawing one line here and perfectly to here, and this is called displacement. In first year you have learned, right? This line is called displacement. If you are going like this, then this is called distance, this is called displacement. So if you can find this length, your answer is over, pakka. That's all. How to find this distance? See, this is the length vector. So what is this side will come? See, this is your length vector. You have something like this one, right? If you do an horizontal, this is L vector, and here 30 degree. Then you are say theta ke pakkathil irikana side L cos 30. You will say this as L sin 30. Then you have another piece of line like this one. This is also L. This is also 30. So this will comes as L cos 30. Opposite side is called L sin 30. So what is your total displacement in this context? So F is equal to I into LB sine of 90. Always angle between L and B. L is like this, B is into the board, so angle between them is 90. That is pakka, no doubt. Next one, I into, instead of L, you have to substitute the displacement value. What's the displacement value? L sin 30 plus L sin 30. So see, L sin 30 plus L sin 30. So L is over. Next one is B sin 90 is 1 now. So 2L, I into 2L sin 30 into B. Sin 30 is what? 1 by 2. 1 by 2, 1 by 2, let 2 cancels. So what is coming as answer? ILB. This is what we got in the previous method also, right? This you can use it. You can use my displacement method. L is called the displacement here. For one conductor, displacement and distance are equal. But for two conductors, where the starting point, where the final point minus starting point, you have to take the shortest distance between these 2 points. That is the answer for this question. Okay. Fine, perfectly. So let's have another question. Find the force experienced by the current carrying conductor. So my next question will be like this. A magnetic field will be here. I have placed a current carrying conductors like this. So its distance is equal to R. Okay. So find the force experienced by the current carrying conductors like this. Okay, next I will apply F is equal to ILB sine theta. Theta is angle between. So this is, if this is the length, okay, this is the length. It's fine. I know this is a length. This is also a length. Magnetic fields are into the board, so it makes 90 degree. Length and magnetic fields are 90 degree. So I into, this is a current carrying conductor. Okay, So you can see this is a starting point, this is a final point. So final point minus initial point. So if you take this distance, this will come half of the length, pi r will come. But if you take this distance, what this will come? R plus R2 R will come. This one, the above one is not displacement. Above one is called distance. This one is the shortest distance between the starting point and initial point. What is the value of this one? 2RB. So answer is 2IRB is the right answer for this question. Always you have to take final point minus initial point. This is a current carrying conductor, starting point, final point. So if you take a full loop, of course, you know this is a starting point, this is an initial point, and you have to take the distance between the starting point and final point. Okay, so I2RB is the right answer. One more question I will do. Find the force experienced by the current carrying conductor placed in a magnetic field. So we have a magnetic field is into the board. Okay, so I have a like this I. So length is called L and L and L and L. So current is going. So I have to apply the formula, a closed loop which is placed in a magnetic field. F is equal to, tell me, ILB sine of how much? 90 degree. Closed loop is like this. Magnetic fields are into this one. Length, magnetic fields are into, length, magnetic fields are into the board. Length, magnetic fields are into the board. Length, magnetic fields are into the board. Sine 90. Everywhere length makes magnetic field with 90 degree, sine 90. So suppose if you assume this is a starting point, starting here, going here, coming here, going here. So this is the initial, or I can say this is something called, what is called start point. So this is your start point. This is equal to your final point. So what is the displacement will be here? 0. Displacement is 0 means I into I multiplied with 0 b sine of 90. Answer is 0, which means to me is like that. For a closed loop placed in a magnetic field, for a closed loop placed in a magnetic field, not experience any force, In the previous question, the current carrying conductor is like this, not like this. This is an extra line, you don't want to confuse. Because in the previous question, the current carrying conductor is like this one. So this is an additional line I have drawn in order to represent it as displacement in the previous question. And this distance is called a distance. So this is not there. Additionally, I have drawn. You can maybe put it as like this. In the previous question I am saying. So that's what. Instead of taking this distance as pi r, in the previous question I have taken this distance. This is given as 2r. So I have to take 2r instead of pi r in the previous question. Previous question, it is not a closed loop like this one. This is a closed loop. It's not a closed loop. It is only an open loop like this. Only this. In the previous question is only like this. I drawn this as additional line in order to get the correct answers. So don't think like, sir, previous question you have drawn like this. No. Previous question I have drawn only this, and an additional line extra I have drawn additionally myself to represent this is called a displacement. So the current will be like this if you are drawing an additional line. But in actual reality, this line is not there. This is an additional line in order to represent this is called displacement, this is called a distance. But whenever it's a closed path, instead of a square, if I place it like a circle, then final point and initial point displacement will be equal to 0, force will be equal to 0. For a closed loop placed in a magnetic field, not experiences any force. Important.